Hi folks, Dr. P here. This is Math 20-2 Statistics, Topic 3, Example 2 on page 25 in your workbooks. In this example here, we will be determining the probability below a value under the normal curve. A grocery store has determined that the average waiting time at an express checkout is 2.5 minutes with a standard deviation of 30 seconds. Assuming a normal distribution, what percentage to the nearest hundredth of customers at the express checkout will wait less than 2 minutes? So the first thing we have to notice here is that the average wait time is using minutes as the unit, while the standard deviation is using seconds as a unit. We need to make sure we are working with the same units. So we're going to start by converting the standard deviation of 30 seconds to minutes. So 30 seconds is half a minute, and 1/2, and if it's divided, we get 0.5 minutes. And then we can move on and look at the normal curve here. We're going to start by labeling it. Along the x-axis, we have the waiting time. And that's going to be in minutes. And along the y-axis, we have the frequency. How many people, or what proportion of people, are waiting a certain amount of time in line. We know that the average waiting time is 2.5 minutes, so this is our average. And then they're asking us what percentage of customers at the express checkout will wait less than 2 minutes. Well, 2 minutes is less than 2.5 minutes. So 2 minutes might be somewhere over here. This is 2 minutes. It doesn't matter exactly where we put it as long as it's to the left of the average because it's a smaller value. And they're asking for waiting less time than 2 minutes. Well, if this is 2 minutes, then less than 2 minutes will be part of the curve, normal curve, that is to the left of 2 minutes. This tail here, that now I'm coloring it with red, would be any time that is less than 2 minutes. To the right, you'll be waiting more than 2 minutes. And if you are to the right of the average, somewhere over here, it means that you would be waiting not just more than 2 minutes, but also longer than the average wait time of 2.5 minutes. So what we're doing here is we are identifying which part of the region under the normal curve that we want to determine the area for. And that is the part that is to the left of 2 minutes. So to do this, we're going to be using our graphing calculator. So we are going to find a probability under this curve to the left here using the function called normal CDF. And normal CDF is using 4 arguments. The first argument is the lower limit, so what's the smallest possible value along the left here, where basically this tail ends? Well, this tail never ends, okay? So technically the lower limit is negative infinity. Now we can't actually enter negative infinity on our calculator. So what we're going to do is we're going to be entering the lower limit as a really, really small value. And one way to do that is to write it as negative 10 to the power of 99, which is a very, very tiny value. And for our purposes here, for all practical purposes, it's equivalent to negative infinity here. The second argument that the calculator requires for the normal CDF function is the upper limit, which in this case is going to be 2 minutes, so just 2. The third argument is going to be the average. The average here was 2.5. And then the fourth argument is the standard deviation in minutes, which is 0.5. So now we're going to be using our calculator. Just going to try and scroll here so we can see everything. Leave it like that. So we're going to turn it on, and then we're going to go to second function and the vars button. So when I press the second function, I'm actually going to go into the dist. It says dister on top here in yellow. And we're going to pick the function that's called normal CDF, which is option number 2. And then it's waiting for our 4 arguments. So the first one was negative 10 to the power of 99. And then we have to put in a comma. The comma on the calculator, on these calculators, is right here. And we put in our upper limit, which is 2, comma, then the mean, which is 2.5, and then the standard deviation, which was 0.5. We press enter. And this number here is the probability that a waiting time in the express checkout will be less than 2 minutes. Okay, now we're not actually looking for the probability, we're looking for the percentage of people that will have to wait for less than 2 minutes. So what we have to do is we have to take this probability and multiply it by 100. So our probability here from the calculator is 0.1586, and then there's more decimals. And then if I take this and I multiply it by 100, multiply this by 100, I'm going to get the percentage of people that will have to wait for 2 minutes or less. And they want this answer to nearest 100th, so 2 decimals, so it's going to be 15.87. So 15.87% of people that are in the express checkout will have to wait less than 2 minutes. That's a wrap. Until next time, stay safe, stay healthy, and may the math be with you. See ya.